Welcome to The Explainer. Today, we're cracking the code on one of the most powerful, predictable, and, let's be honest, kind of mysterious forces on our planet, the tides. I mean, if you've ever been to the beach, you've seen this happen. You watch the water just creep up the sand, and then a few hours later, it's all the way back out again. It almost feels like the Earth is breathing. So, what's really going on?
Well, this rhythmic movement is definitely not random. It's basically a cosmic tug of war. Gravity's a rope, and our planet is caught smack in the middle. So, who's doing all the pulling? Let's dive into the main player.
In this celestial showdown, the heavyweight champion, at least when it comes to tides, is our closest neighbor, the moon. Its gravitational pull is the #1 reason we even have tides at all.
So, what exactly is an ocean tide? Well, the official definition is pretty straightforward. It's the periodic, which just means repeating, rise and fall of the ocean's surface. And it's all driven by that gravitational pull between the Earth, the moon, and even the sun. So here's the deal. The moon's gravity is kind of like a magnet, right? It's pulling on everything on Earth. But, and this is the key, its pull is strongest on the parts that are closest to it. So the ocean on the side of Earth facing the moon gets tugged just a little bit more than the solid planet itself. That water piles up, creating a tidal bulge. And there you have it, that's our first high tide. Okay, that makes sense for one high tide. But most coastlines get 2 high tides every day. If the moon is only on one side of the planet, where on Earth is the second one coming from? And here is the part that's going to bend your brain a little. On the far side of the planet, the moon's pull is at its weakest. So get this. The moon pulls on the solid Earth a bit harder than it pulls on the water on that far side. So the planet is literally pulled away from the water, which gets left behind, creating a second bulge. So as our planet spins, every single coastline rotates through both of these watery bulges each day. This cosmic chase means the time between high tides isn't a perfect 12 hours. Nope, it's a little longer, because the Earth has to spin just a bit extra to catch up to the moon as it orbits around us. The result? A high tide rolls in with incredible predictability every 12 hours and 25 minutes. All right, so the moon is clearly the star of the show. But you might be wondering, what about the sun? It's unimaginably massive. Shouldn't its gravity just dominate everything? And that question leads to a fascinating paradox. And here's the solution to that paradox. The sun is way more massive, but it's also incredibly far away. And when it comes to tides, what really matters isn't the total gravitational pull, it's the difference in that pull from one side of Earth to the other. You know, that stretching effect. Because the moon is so close, its pull changes a lot across the planet, stretching it into those bulges. The sun's pull is more uniform. So even with its massive size, the sun's tidal effect is only about half as strong as the moon's. So we have these two forces pulling on our oceans. And when they start interacting, things get really interesting. That's when we see the most dramatic tides on Earth, when the sun and moon either team up or pull against each other. This is what we call a spring tide. And no, it has nothing to do with the season. Think spring as in to spring forth. It happens during a new moon or a full moon, when the sun, Earth, and moon are all lined up. Their gravitational forces combine, they're yanking together, and that creates the most extreme tides, the highest high tides and the lowest low tide. And then you have the complete opposite, a neap tide. This is what happens when the sun and moon are at a right angle to each other. In this version of the tug of war, they're pulling in different directions. The sun's gravity actually cancels out some of the moon's pull, giving us the most moderate, chilled-out tides of the month, the smallest possible difference between high and low tide. This whole cycle just follows the phases of the moon with clockwork precision. You get a spring tide, then about a week later a neap tide, then another week later the next spring tide. That means there are about 14 days between those most extreme tides. So this is a fascinating cosmic dance, but why does it actually matter to us here on Earth? Well, it turns out that understanding this rhythm is absolutely critical for everything from building our cities to catching a good wave. And these impacts are huge. If you're building near the coast, you have to know the high watermark of a spring tide. Otherwise, you risk some serious flooding. That flooding gets especially dangerous when a big storm hits at the same time as one of these extreme tides. This rhythm also creates a really unique habitat, the intertidal zone, for tough little creatures like barnacles. And of course, if you're a surfer, the tide chart is your Bible. An incoming tide can make all the difference. This really gets to the heart of what a special environment this is. The intertidal zone is a world of constant change. Life there has to be tough enough to survive being submerged in salt water and then, just a few hours later, completely exposed to the air and sun. It is a wild place to live.
Now let's switch gears and see how this ancient, predictable rhythm can actually give us a glimpse into our planet's future.
So there's this special type of spring tide called a king tide. This is the big one, the highest high tide of the entire year. It only happens when a couple of things line up perfectly. You get the sun, earth, and moon aligned for a spring tide, and at the same time, the moon is at its closest point to Earth in its orbit. It's the perfect tidal storm.
And this is exactly why paying attention to tides is more important than ever. Scientists are starting to look at these king tides as a real-world preview of our future. The kind of nuisance flooding that we see during a king tide today could very easily become the new normal high tide in a world with rising sea levels. It's a powerful and kind of scary way to visualize what's coming. And it leaves us with a pretty critical question. When we watch a king tide, are we just looking at the highest tide of the year, or are we looking at our children's everyday reality?